in case of when we are electrolyzing the water, for example. So, sir, we have the full electrolytic cell like this one,
Uh-huh.
like we have the positive and negative terminals, and we have them dipped in the ionized water and like that. So, sir, that full apparatus will be known as the electrolytic cell.
Okay, that is good. So what convert, that is the one cell is there where the electrical cell is converted electrical energy is converting into chemical energy. Another cell is there, chemical energy is converting into electrical energy. What about this electrolytic cell? What about this one? What happened in this? Which energy is converted in what?
Sir,
Huh?
that is the sir, electrical energy is being converted into the chemical energy.
Thank you very much. So electrical energy is converted into, that is what? Converted into chemical energy. Into chemical energy. Getting chemical energy. So this is the point is there. Electrical energy is converted into chemical energy. That now, see, unlike the galvanic cell, if you see, difference already we have done in the electrical energy, electrochemical cell and electrolytic cell. So here galvanic cell, if you see, that is there are the two cell was there. Yes, yeah, no. This is the two cell. Galvanic cell was there, two cell. Here, and that cell is also connected with the salt bridge. Any idea? Do you know this cell? Have you seen this cell? And here we were producing the electricity. If you are taking zinc and copper electrode, it is the 1.10 volt it was coming. But
That is the
here is
equilibrium point. Na? That
but
is the equilibrium.
if you talk about the electrolytic cell, so electrolytic cell is made up of only one cell. Do you know this one? Electrolytic cell is made up of only one cell, not two cell. And both the electrodes are being kept into the same cell. This is there. Both the electrodes are in the same cell. So here what is happening? We are connecting with the battery. We are connecting. And here we are connected with the voltmeter to get the voltage. And here we are connecting with the battery. Now, if you see, if you are putting this one, what the electrolyte is there. So what will happen? What will happen? That is positive. This is the suppose negative and this is positive. So positive charge will be deposited here. Positive charge is going to be deposited here on the which one? This is on the cathode and negative charge is going to deposit on the anode. Okay. So this is the process of electrolysis. Suppose you are taking the NaCl. Okay. So what will happen? That is Na is there. If I am talking about molten NaCl, molten. So what will happen? Na plus it will give and Cl minus it will give. So Na plus will be taking one electron and it will convert into Na at what? That is at cathode. At cathode. Just I'm telling you definition. And Cl minus, take the two molecule of Cl minus. So it will give the Cl2 plus 2 electron. This is going to be at anode. And if you talk in detail, so here is what is happening in this case. You will find that at anode, that is oxidation, minus 2 0 oxidation. And here is plus 2 0, that is reduction. So these both the redox process taking place into the only one cell. That is what is called electrolytic cell. Electrolytic cell. Getting my point?
Yes, sir.
So this is the
Getting.
this is the definition. Now, Sanoy, the important things, that is the when you are putting the doing the electrolysis process, then you need to know that is what are the factors getting involved in the process of electrolysis. Okay, what are the factors? The first factor of factors involving in electrolysis. In electrolysis, what are the factor is going to be involved? So let us see the factor. The first factor, if I will talk about, the first factor is resistance. Have you heard about the resistance? No.
What about resistance, sir?
Second one is resistivity. Second one is conductance. Conductance. Okay, conductance. Fourth one is conductivity. Conductivity. Fifth one is the cell constant. Cell constant. Cell constant. Okay. Okay. Sixth one is the conductivity. Conductivity already we have done. Molar conductivity. These are the point related to molar conductivity. One more is there. Seventh number. Equivalent conductivity. Equivalent conductivity. Equivalent conductivity. So how many factors are being used in the electrolytic cell? That is what is there. Resistance is there. Resistivity. Resistivity means specific resistance. Resistance is represented by capital R. Resistivity is represented by rho. Conductance is represented by G. Conductivity represented by K. Cell constant is represented by G star. Molar conductivity lambda M. Equivalent conductivity lambda EQ. So these are total 7 are there. So one by one we have to understand. Whenever you are
Sir,
flowing the
no.
no, that is normally I'm just speaking. When you are flowing the electricity, okay, in any of the medium or through the wire, through the water, through the electrolyte, so there must be some resistance. Yes or no?
Yes, sir.
If there is no resistance, so the electricity can reach anywhere in the same amount, but it's never happened. What will be there? Resistance. Obviously, there will be the resistance. Compulsory, there will be resistance. So, what is the resistance? Can you define the resistance?
Resistance is the something that opposes the flow of electric current.
Okay, that is the correctly you are saying resistance. It you are saying it. What it do, Sanoy? It obstruct the flow of current. The flow of current. Okay, it's going to obstruct the flow of current. So what it is going to defend, and what factor it is going to depend? Can you tell me? Resistance depends on what?
Material, sir, which material we are using? What is the diameter of the wire?
So length also, na? So that is
Yes,
resistance is proportional to length. Longer the length of wire, greater will be resistance. Yes or no?
yes, sir.
Like your car is running on the road, so greater the distance it is going to cover, greater will be the resistance in the your tire will be there. Okay, but and secondly, resistance is inversely proportional to area of cross section. If the wire is wider, so easily current will flow. So similarly, this is area of cross section of electrode. This is the area of cross section of electrode. So this is the equation number 1. This is the equation number 2. If I will merge this equation, so what is there from 1 and 2? So 1 and 2 are proportional to L by A. This there. So if you remove R equal to rho L by A. Okay, R. This is there, R equal to rho L by A. Now, Sanoji, what you will find? That is L is what is length. Length of wire or anything you can say. A, area of cross section. This is the area of cross section. This is the area of cross section. Rho is resistivity. Resistivity. Resistivity is this is the also called specific resistance. Resistivity is fixed for the particular material. R is resistance. R is resistance. Now, you see if I will talk about the unit of resistance. What is unit of resistance? Unit of resistance you must be knowing what is there. This is the ohm. This is OHM. This is what? Ohm. Right?
Omega.
Huh. No, ohm. That is what is called not omega. Okay. We either you represent by omega or then you call what? Ohm.
Symbol is omega, the name is omega.
Ohm. Okay. Now, what I am doing here, this is okay, na? Now we are talking about resistivity. 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 It is, can you define the resistivity? It is also called specific resistance. Specific resistance. It is also called specific resistance. And is what's if I will talk, and is equal to resistance if length is unit length. I am writing if length is 1 centimeter and area of cross section is how much? Area of cross section is 1 centimeter square. Either you can write 1 meter, then 1 meter square. So here you see R is equal to what we got? Rho L by A. You put the value. So R is equal to what we get? Rho 1 by 1. So it will be cancelled out. So R is equal to rho. So it is the specific resistance when what is there? When the length and area of cross section is unity. Now here you see unit of resistivity. Unit of resistivity. That is rho. So what is there we can write? So
Inverse.
R is equal to that is okay, that you can say R is equal to rho L by A is there. So rho is equal to R A by L. R is what is there? Ohm. A is there, centimeter square divided by centimeter. 1 centimeter, 1 centimeter, cancel. So what will be there? Rho is equal to ohm centimeter. This is the unit. Or another will be there. Rho is equal to ohm meter. Anything is possible. Either in what unit you are calculating that determine. Are you getting this? Hello?
Getting.
Can I reach? Can I reach?
Yes, sir. Yes, so one second.
Uh-huh.
Done.
Okay. Now, Sanoy, the other factor you read the other one also. The same place we are studying conductivity. Okay. We are writing the conductivity. What is conductivity, Sanoy? What is
Sir,
what
I
do
don't know actually this things. I forgot.
no problem, no problem. Here you see conductivity. This is the conductivity. If you talk about conductivity, that is the represented by K. Okay. What they are saying, it is conductance. It is the conductance of ions produced ions produced or ion present, that is what you can say, ion present between between the electrodes electrodes between the electrodes of unit length and unit area of cross section cross section. Or that is the same things you can determine. Or how can you determine the another things? You put the or. This is the or. Okay. So what is the conductance? I am saying conductivity. Is conductivity is inversely proportional to resistivity. Inversely proportional to resistivity. Okay. So K is equal to 1 by rho. Conductivity inversely proportional to resistivity. Now you know, since we know R is equal to rho L by A, so rho is equal to R A by L. So this value you are going to put here. Getting? Now, what you are going to get? So K is equal to 1 upon R A by L. This one. So K is equal to, oh,
1 upon
sorry,
RA by L it will be there, sir.
it is L. So K is equal to, what we can write, Sanoe?
L by RA.
1 upon R is okay into L by A. Is it okay?
Yes, sir.
Now come here. See. So R is equal to rho L by A, that we read. Now second condition you see this much also. Now K value here not given, K value. If you see K, this is the conductance now. Just give me 1 minute. Where is the conductivity? Just searching. Here not there. Huh. Here is also not there or what? Just I am showing you. This is the K. You can correlate this one. So can it be K is equal to what from here? What will be there? K is equal to R will go this side. So what will be there? K equal to 1 by R into L by A. Will it come from this expression? Tell me. Here this is,
What we have to fix, sir?
I'm just saying that is what we derive. This is correct now according to book.
Correct only.
Correct only. Just I'm just want to show you. That is why. Because you may when you read now, you must not get any problem. This is there. Now you read anything, something in the NCERT book, then it will be very much clear to you. Okay?
Yes, I will read it. Today or
See,
tomorrow I will read.
wait. I'm showing you something. Now cell constant. I'm telling some more point. Cell constant, that is G star. Cell constant is the G star. And what is this one? Ratio of length and area of cross section. Ratio of length and area of cross section. That is G star is equal to L by A. G is equal G star. अब relationship between, here we are saying relationship between these are very important point which I am telling you. Relationship between conductivity. This is the conductivity, comma, cell constant and resistant. These are the problem. Relationship between conductivity, cell constant and resistant. So what can be, Sanoy? You see, please. This is the conductivity, cell constant G star, resistance R. So how can we derive this one? How can we? So R is equal to
G star is
rho.
the cell constant, no, sir.
What?
I'm saying, sir, G star is the cell constant, isn't it, sir?
Yes. R is equal to rho L by A. Can we write this one? R is equal to rho L by A.
Yes, sir.
From resistance. So
Yes, sir. We can write.
what R is equal to rho into G star. Can we write this one? G star is equal to what? L by A. Can we write like that?
Yes, sir.
So if I will write that G star is equal to R by rho, can we write R by rho?
Yes, sir.
Okay. Can I write K is equal to 1 by rho? Conductivity is equal to conductivity inversely proportional to resistivity. Can I write?
Yes, sir.
So G star is equal to what will be? R K. Check it.
Yes, sir.
Confirm now?
Yes, sir.
Okay. So when you read the NCRT book now, so many things you will get. But that things may be complex form they
Yes,
have
sir.
given.
They're writing in a bit complex manner, so not very easy to understand.
But here you see what we derive, that is can you see this one? Our
Yes, sir.
derivation. So here, so what is G star is equal to RK. RK is coming. Yes, yeah, no.
Yes, sir.
Okay. So unit already I told you. Up now, molar conductivity. You just read the molar conductivity. Molar conductivity. Molar conductivity. What is molar conductivity? Lambda m. So what is? It is conductance. It is conductance of 1 mole of electrolyte. Conductance of 1 mole of electrolyte. Electrolyte. So this is conductance of 1 mole electrolyte. Now, if you see molar conductivity, so lambda m is equal to, this is K by C. This is K by C. C is concentration. C is concentration. C is concentration. Here at the place of conductance, you can write conductivity also. There is no problem. Conductivity. Okay. For 1 mole and both are the same. So C is equal to what is? Molar concentration. This is molar concentration. That is mole per liter. Mole per liter. Okay. So mole per liter. So what we can write? Lambda m is equal to K upon molarity is there. 1 liter is equal to 1 liter is equal to 1000 ml. So K by M is there. Okay. And then what is there? 1 liter is equal to 1000 ml is also there. So what is there? M upon what we can write? 1000. So lambda M is equal to K into 1000 upon molarity. Lambda M is equal to K into 1000 upon molarity.
So I'm writing this one, sir.
No problem. You write. You take your time. So weekly only one day you are studying the mathematics.
Sir, weekly 2 day, Wednesday and Saturday.
Wednesday what time?
Wednesday, sir, 19.
Okay, okay. Mhm.
But sir, the other 5 days I'm free.
Okay, okay. Okay.
Sir, this annual examination, sir, in the this one, sir, out of 100, sir, I scored the highest in mathematics only, sir.
Acha, your is mathematics.
Yes, sir.
How much you got?
No, no, sir. I mean I don't know what is the highest in my class. Sir, among the other science subject, I got the most highest marks in mathematics only.
Okay, okay. That is how much? That I want to know.
I'm 87 out of 100.
Acha, 87 is good marks here. And chemistry already you told me 47 something.
40, 43, sir.
43 and physics 42.
Yes, sir. Sir, among the physics, chemistry, and biology, sir, chemistry only highest.
Mm-hmm. It's okay, but okay, no problem. Now let us. This you got to know, na answer.
Yes, sir.
Now another things. Here, unit of conductivity. Here we are going. Unit of conductivity. Unit of conductivity. Unit of conductivity. Unit is very important for board exam. Getting my point? Very, very. If you don't write the unit, half marks will be reduced. Unit of conductivity. So just now we did the conductivity equation. So what we got, K is equal to, we derive conductivity 1 upon resistivity. So K is equal to 1 upon resistivity is equal to, wait, Sanoy, let us derive in the proper manner. Otherwise, you will get confused. R is equal to rho L by A. So rho is equal to RA by L. So if you put that is the in the formula, so this is RA and this is going to be L. Okay. So RA by L. Now K is equal to what will be there? Oh, here if you see, uh, 1 upon R is equal to what we can write? 1 upon ohm, or you can write ohm inverse, or that is what is called Simon. Simen. This is called Simon. Simon. Ohm inverse is called Simon. Simen. Ohm inverse is called Simon. Or 1 by ohm is also called Simon. So what we can write? See. So let us 1 by ohm multiply by centimeter upon centimeter square. Getting? So what will happen? This centimeter and this centimeter will cancel out. So K is equal to 1 by ohm. So this will be ohm inverse, and that is centimeter inverse. So K is equal to, you can write ohm inverse, that is called Simon. SI unit is Simon. Centimeter inverse, or K is equal to S centimeter inverse. S for Simon, or K is equal to S meter inverse. This is there. Can't you understand this?
Yes, sir.
Can I erase this?
Yes, sir.
So, unit of molar conductivity. Unit of molar conductivity.
Sir,
Molar.
how many more days this chapter will take, sir, to complete?
Tomorrow you can finish. Tomorrow you join. Tomorrow will finish. Tomorrow theory will finish. 1-2 days I will take for numerical, because I don't know how you are doing numerical. So we'll do here online fully. Okay, I don't want to leave any loopholes. Unit of molar conductivity. Okay, that is lambda m. So derivation already we have done. Lambda m is equal to K into 1000 upon what is m. So K is what is there? Simon, centimeter inverse, mole inverse. Simon, centimeter inverse, mole inverse. Okay. Or it can also be Simon, meter inverse, mole inverse. Getting my
Understood.
point? Understood.
Getting,
Good,
sir.
good. Now let us, then if you are getting, then let us solve the problem. Then what is the problem? Okay. Here they are saying resistance of a conductivity cell filled with 0.1 mole per liter KCl solution is 100 rho. So their molarity they are talking about 0.12 o'clock. 0.1, what will be there, Sanoy? 0.1 mole liter inverse. Okay, this is one thing. Resistance they have given how much? This is the 100 ohm. Okay. Now, students see, this is the one point we have done. Resistance of conductivity cell, that is, if the resistance of the same cell. What the point here? Very, very important. You need to keep in mind, same cell is there na. If the same cell is the same, then cell constant will also be same. Getting my point? Hello?
Getting, sir.
They are saying when filled with 0.02 mole per liter. Now the case second they are talking about. Here is case 1 is there and this side case what is there? Case 2. So they are saying when filled with 0.02 mole per liter. So molarity they are talking about 0.02 mole per liter. That is, this is reduced. KCl solution is 520 ohm. So R is equal to how much it is? 520 ohm. Calculate the conductivity and molar conductivity of 0.02 mole per liter solution. K they are asking. Then what they are asking? K, that is okay. Lambda m also asking. Lambda m. Next what they are saying? The conductivity of 0.1 mole per liter KCl solution is 1.29 Simon meter. So here they have given 1.29. What is Simon per meter? So this is given, but here the concentration change means the conductivity will also change. So now what will be the same cell is there, same cell, since I am writing, here I am writing, since cell is same, since cell is same. So what we can write? So cell constant, cell is same. So cell constant will also be same, will also be same, will also be same. Yes or no?
Yes, sir.
So what is the cell constant? G star is equal to RK. If you know the relation, do you know this relation? G star is equal to RK. Yes or no?
Equal to RQ just talked na some time ago.
So R value they have given how much? 100 ohm. 100 ohm. K value they have given 1.29 Simon meter inverse. Now, see Sanoy. Simon is what? 1 by ohm. This is ohm. This will be cancelled out. So how much will coming? 129. This is meter inverse. G star. Can you understand this one? Cell constant. Tell me yes or no.
Yes, sir.
So now here we are calculating the conductivity. So K is equal to just now we have done one relation. So G star is equal to RK. G star is equal to RK. So K is equal to G star by R. So G star value we got to know 129 meter inverse. And R value can you see? 520 ohm. 520 ohm. So you solve this one and take the answer, check the answer, how much is coming. So just I'm dividing 129 divided by 520.
Sir, this is S. You have written this one.
Huh?
What I have circled, that is S. You have written, sir. S.
Simon meter, na. Simon meter inverse. The Simon per meter, S. So it is 0.248. This is there, 0.248. And what the, if you are going to write the unit, so unit is going to be what? That is
This is what this one.
cell
This one, sir.
constant, TANT, cell constant. So here is 0.248 and unit if you write that is ohm inverse is going to be what? Simon and meter inverse, Simon meter inverse. So K value we got somewhere, K value 0.248, that is Simon meter inverse. This is. Now they are asking the one more things we have to calculate lambda m value. Now see Lambda m. What is the lambda?
Sir, you don't stop. 1 second only. I did not could not write full.
What is the lambda m? I am explaining. You can understand first, then you write. So lambda m is equal to k by c. Okay. Now see, all the units should be same. So c means what? Molarity. And here is molarity they have given 0.02 mole per liter. And here you see unit they have given, that is Simon meter inverse. So 1 liter is equal to, if I will ask you 1 liter is equal to how many meter? Can you tell me 1 liter is equal to how many meter? In meter, how much it will be there?
10 power minus 3 meter cube.
10 power minus 3 meter cube or per meter cube?
Meter cube.
This one you are saying 10 power minus 3 per meter cube. 10 power minus
10
3
power
meter.
minus 3 meter cube is 1 liter.
Okay.
That is what I'm saying.
So see here they have said molarity they have given. Molarity is equal to 0.02 mole liter inverse. That means what we can write? 0.02 mole upon what is there? Liter. At the liter what we can write? 0.02. This is mole, let it be. At the place of liter, can we write that is 10 power minus 3 meter cube? Can we write?
Yes, sir.
You keep on watching what I am doing here. So you just reverse
Yes,
it.
sir.
So if you solve this one, how much it will come? It will come 20. Okay. Mole on meter cube, per meter cube. Because 30 will go in the numerator. So 20 will cancel out this value and 10 will be left. So 20 mole meter cube per meter cube. Will it come?
Yes, sir. It will come only.
So lambda m is equal to k value I am putting 0.248. This is Simon meter inverse divided by 20. This is the mole meter per meter cube. Now solve this one. If you divide with the 20, so it is coming somewhere how much? 0.0124. This is there. And here the unit you see, this is the, what will happen? This meter cube is there, it will go in the, this will cancel out, it will become meter square. So Simon meter square mole inverse. Simon meter square mole inverse. This is lambda m. Simon meter square mole inverse. Can you check?
Sir, you just keep the slides for 1 minute, sir. Let me write and checking also.
Okay, okay. Done.
Sir, okay, sir. This one is lambda or what you have written?
Lambda m. It is a looking pi, na? It is looking
Yes,
pi.
sir.
This is lambda. Molar conductivity. Can
Done,
you
sir.
read it? Okay. This problem is clear, na? This is NCRT
Yes.
example only. NCRT example only. You can see the answer. Answer you can see. Here in the NCRT, little bit error is there in the answer. Little bit error is there. You match. Is there, that is the 0.248 Simon meter inverse? K value same. You got K value is same.
Okay.
Molarity 20 mole per meter cube.
Yes, sir.
Lambda m value, you see, lambda m value in the term of, here see 124 power 10 power 124 power 10 power 4. And how
Same.
much we this power is little bit error because we calculate 0.0124. This was there.
Power is correct only, sir. If you check, power is correct only.
Correct only, na?
Yes, sir. Correct only.
If you are putting in the scientific notation 124 into 10 power minus 4. Correct, I think. But it should be
Yes, sir.
like that 1.24 into 10 power minus 2, so more appropriate.
That should be there.
This is the scientific notation. So not a problem for us. Whatever they gave, that we have to consider. This is example number 3.5. See, the electrical resistance of column 0.05 mole per liter. Column means electrode. 0.05 mole per liter NaOH solution of diameter 1 centimeter. So first of molarity they have given, I think, 0.05 mole per liter, and diameter they have given, diameter 1 centimeter is there. Okay. Length also they have given 50 centimeter L. So diameter 1 centimeter, length is equal to 50 centimeter. Okay.
Radius we don't require here. Radius. No.
Radius not given, so radius you can calculate d by 2. So 1 by 2 means 0.5 centimeter. What is their electrical resistance? This is the resistance also they have given, R. 5.55 into 10 power 3. This is the ohm. Calculate its resistivity, conductivity, and molar conductivity. So how many factors they are asking? Resistivity, conductivity, lambda m.
Molar conductivity.
So few things are very easy to calculate. See, resistivity, I will calculate resistivity. Resistivity. So resistivity is the equal to 1 upon what? Resistance.
Yes, sir.
So what will be there? 1 upon resistance they have given, no? What will be there? 5.5.
I given the 5.55 into 10 power 3.
Resistivity. No. This is not the correct one. This way we cannot do. First of all, you calculate the A. A equal to what is that? Is pi r square. Pi r square. Pi value 3.14. R value is 0.5 multiplied by 0.5. So how much we will get? See. So 3.14 multiply 0.5 multiply by 0.5. So it is coming 0.785. This is going to be centimeter square. This we got A. L already there 50 centimeter, right? So what the formula we have learned, that formula only we can use. So conductivity. So R is equal to L by A, na, this one. So what will be resistivity if you are writing? So RA by L. So R value they have given 5.55 into 10 power 3 multiply by A 0.785, and L is there, I think 50. Okay. So now you solve it out, please. 5.55 multiply by 0.785 divided by it is 50. 87 it is coming, so no, how much? 87.135. This is the resistivity. Okay. If you check in the book, it will be the same. If you want, you can check. Unit, just a unit, what will be there? This is the ohm will be there, 1 centimeter ohm. Centimeter. How, why inverse? By what rule you are saying inverse? There A is the centimeter square. This is C. This is ohm. A is centimeter square. This is centimeter. This is ohm centimeter only. Done. Now conductivity. What is the formula? Conductivity. Just now we defined the conductivity. Conductivity. So conductivity is what? K. This is in equal to 1 upon what is resistivity? Resistivity. So what will be there? 1 upon resistivity means rho. So 1 upon what will be there? 87.135. You can divide this one. And if you want to write the unit, that is, this is the ohm inverse, centimeter inverse. No. Ohm is the ohm centimeter. This is already there. So you can divide 1 upon 87.135. So this value is going to be in what? This is there 0.0114. Ohm will go in the numerator. So ohm inverse means this is the Simon centimeter inverse. So K unit already I teach you now. So K is equal to 0.01148 or the 4 only like 3 digit, that is more than enough. This is then it will be the Simon centimeter inverse. Now they are asking one more things, they are asking lambda m. So lambda m also you can calculate. What is the lambda m value? A into 1000 upon concentration molarity. K they have given 0.0114. If I will put the concentration, but this is the what the unit are very important. If you don't keep in mind unit, you won't be able to solve the problem. Simon centimeter inverse means this value, molarity values, what is the concentration are there, that should also be in the same unit. So I am not converting this one actually. Why we are not multiplying by 1000? Because it is not in the liter. It is not the liter. We are not. If it is the ml, then you are converting in liter, then it will be 1000. Otherwise, in what this is centimeter is there. So let us find out what the concentration they have given. Okay, you check the concentration 0.05 mole per liter. This is there 0.05 mole per liter. So here 0.05 mole per liter. This is there. Now 1 liter is equal to how much centimeter? In centimeter, how much will be there? 1 liter is equal to how much centimeter? 1000? 1000 centimeter cube. Is it correct?
Yes, sir. Correct.
Thank you. Thank you very much, Sanoy. So what is there here? Concentration. I'm firstly writing concentration, this one. So it is 0.05. This let it be mole upon it is the liter. Correct now? Liter inverse is there. So I'm writing liter. So I'm writing 0.0114 Simon centimeter inverse. Then divided by 0.05. This is going to be mole. Liter value you are telling only 1000 centimeter cube. Now you are saying to solve this one. So this 1000 will be going in the numerator 0.0114 and this is the 1000. Then it is the Simon centimeter inverse, mole inverse, then centimeter cube. This cube and this one is going to be cancelled out. So this is how much will come? I think 11.4. This will come Simon centimeter square mole inverse. Okay, this is the lambda m value. Are you getting this? Let me check the answer, please. Otherwise, if anything is missed. Hello. This is the little bit different. What is the problem here? K value we have kept 0.0114. This is the correct one. This is correct one. Divided by 0.05. How much we are divided? Acha, this value is we left now. We have to divide this also. This is there na. This is only we send this one there. But here 0.05 is there already. Here also we have to divide 0.05. Are you getting this one?
Not getting.
Not getting. Why not getting? Where is the problem? 0.05 to
What
2a.
you were writing that is also not visible.
Still not visible. These are what I am erasing, not visible.
Now erasing that is visible. Earlier you were writing it was not visible.
Acha. Now, up to here is okay. Up to here what I wrote.
Yes, yes, okay.
So it is coming 228 Simon centimeter square mole inverse. This is value what lambda m. You can check here. What is the value? 229.6. Little bit approx figure. Because
Could
they
you
are
please
taking.
the slide that I was
No, no,
writing?
no. Okay, first of all, you check the answer whether correct or not. 87.135 correct?
Yes, sir.
0.00114, that is correct.
Yes,
And
sir.
here is 229.6, that is also correct. So here, the same. Where should I do? What should I do? See, where you are writing.
This much only you keep. I will be done.
Right, right, right.
We're done.
Okay, okay, okay. So this problem we have done. No? Now, what you do tomorrow, you are having some time. Just you read these slides, whatever they are. Like these are there here, you see. It is necessary to define the few terms before we consider the subject of conductance of electricity through electrolytic solution. The electrical, this is NCERT only. The electrical resistance represented by symbol R, it is measured in the ohm, which is termed of which in turn of SI base unit is equal to kg meter square per no S cube A square. It can be measured with the help of Wheatstone bridge. Okay, so this much detail not required, but they can ask that is how you are going to measure the resistance Wheatstone bridge, with which you are familiar from your study of physics. The electrical resistance of any object is directly proportional to length, that already we done, inversely proportional to area of cross section A, that already I explained you, everything I explained you. So these slides, whatever the NCERT are there, that you know, need to read. The constant of proportionality, rho, called what is resistivity. Either you can say specific resistance. Its SI unit is ohm meter or ohm centimeter. And quite often it is sub multiple ohm centimeter. Either say ohm meter or ohm centimeter. It is also used. IPSC nomenclature, the use of the term resistivity over specific resistance, and hence in the rest of the book we shall use the term resistivity. So earlier it was knowing that specific resistance. Now it become resistivity. Physically, the resistivity of a substance is its resistance when it is 1 meter long and area of cross section is 1 meter square. That I explained if you are remembering anything. Got it?
Yes,
The
sir.
inverse of resistance is called conductance. That is conductance is G.
Hmm.
And we have the relation G is equal to 1 by R. And R value you are putting. So G is equal to A rho by L. A rho L. Or you can say K, 1 by rho means what? K, A by L. Again, I am defining this one. G is equal to, this is conductance, 1 upon R, and R you know now, R is equal to rho L by A. So you can put the value. So G is equal to 1 upon rho L and A will be up. So this value, G is equal to A upon rho L. And 1 K is equal to what is? 1 upon rho. So 1 upon rho is equal to K. So G is equal to, we can write K A by L. This relation, are you getting?
Yes, sir.
So this relation you should know. You read this point, all the point, this you will be able to understand very easily. There is nothing tough. The SI unit of conductance is Simon. What the SIEMENS? It is represented by the symbol S and is equal to ohm inverse. Simon is equal to what? Ohm inverse. I already teach you. Also known as Maho, MHO, Maho. Okay, ohm is what? This is the ohm. But if it is the ohm inverse, that is called Maho. The inverse of resistivity called conductivity. Inverse of resistivity is called conductivity. Specific conductance is represented by symbol K, Greek called kappa. Conductivity is represented by K and its Greek word is kappa. UPSC recommendation, the use of term conductivity over specific conductance, and hence we shall use the term conductivity in the rest of book. So in spite of using a specific conductance, we are going to use the conductivity. The SI unit of conductivity are the Simon meter inverse, but quite often expresses Simon centimeter inverse. Conductivity of material Simon meter inverse is its conductance when it is the 1 meter long and its area of cross section is 1 meter square. It may be noted that 1 Simon centimeter inverse is equal to 100 Simon meter inverse. So this is very easy. So can you read this one by yourself?
Yes,
So tomorrow I will be starting to you checking the what the slide is there. This one. Variation of conductivity, molar conductivity with concentration. This and battery. Then this chapter will be over. And then we will do the numerical. So slowly you read. If any point you are not able to, just I will explain to you. Already I explained, by the way, but you try to learn. Okay.
okay.
Now it is 12 o'clock, so you can sleep or as you wish. If you want to study, you can study also, no problem. So, but I am going to have the dinner. Till now, I did not take the dinner also. Okay. So, I am going now.
Okay.
Okay.
Thank you.
Bye.
Good night.
Good night. Good night. Good night, beta.